So the first of the two types of collisions we'll be dealing with is inelastic collision. In this case, both momentum and kinetic energy are conserved. So you'll want to set up your P initial equals P final business and KE initial equals KE final business. Oftentimes, these are used, actually most of the time in this chapter anyway, these are used as a system of equations. You're not given enough information to completely solve for, say, velocity final, for example. Uh, so you'll need the velocity final in this one to substitute into this one, etc., etc. There are some where you think you have three unknowns with just these two equations, and you're like, well, what's the third equation? You just have to trust that that third variable is going to cancel out. The way these two equations interact is pretty neat. You got mv dot 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 equals mv yada yada yada, and over here you got, for kinetic energy, you got 1/2 mv squared dot 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 equals 1/2 mv squared dot dot dot. Now I'm missing a lot of like m1s, m2s, v finals, v initials here, but see how similar these are? Similar. You got m's, which could cancel out easily. You got the v's here, which could cancel out. So if you think you have too many unknowns, even with these two equations, just trust the algebra that it's going to work out, and it's actually pretty beautiful how it often works out. So that's pretty much all I need to say for these. I'm going to do some sample problems where you'll see this in action, but it's actually pretty straightforward, and the algebra is not too bad. So just think system of equations. Then we got inelastic collisions, and now that I'm doing this, I probably could have fit this all in one video, but you know what? Whatever. Anyway, so inelastic collisions, kinetic energy is not conserved, so objects completely stick together. You're not going to have a kinetic energy initial equals kinetic energy final for this. At the very least, or at the very most, or I don't know, whatever, you may have a kinetic energy equation because in the problem a certain percentage of kinetic energy is lost, which is actually a more realistic type problem, but you're not going to have true conservation of kinetic energy where KE initial equals KE final. So you're just going to have P initial equals P final, but what's going to happen is, so you have two objects that stick together, you'll have M1 V1 initial plus M2 V2 initial. It's going to equal M1 plus M2. They stick together and they go off at a common velocity. We'll say velocity of 1, 2 together, final, something like that. So that's how you'd set up your equation. This could be in reverse, by the way. You could have an explosion, which is sort of a reverse inelastic collision, where you start off with the two objects stuck together, and maybe since it's an explosion, they initially start off at rest, which is interesting. It makes things easier. So you have a velocity initial of 0, and then they split up. M1 V1 final plus M2 V2 final. And so, yeah, I think it's if this is not enough, then definitely look at the sample problems to see some of this in action. It's actually at this point pretty straightforward concept, not too tricky. Is there anything else I wanted to say about this? No. All right. Well, nice short video. Got one more slide. Basically, I've said this multiple times already in the past, in this video and the past video. Collisions in real life are not purely inelastic or purely elastic. They're actually somewhere in between. So when you have a ball that you drop from this height, a purely elastic collision, the ball would bounce back up to the same height. A purely inelastic collision, the ball would just stop here with 0 bouncing. Good luck finding an object to do either of these. You're going to get basically ball dropping, ball bouncing up to some intermediate height, depending on how elasticy or inelasticy the ball or the object is. Some balls, they're called bouncy balls. You might have had fun with them as a kid or as you are now. They bounce pretty high, back pretty close up to their original height. But yeah, anyway, so that's it for collisions. It's actually not too much extra, considering that we talked a lot about momentum already in chapter 9a. So I'll let you go with this. Bye bye.